Hi, this is Anshu, and in today's session, I'm going to discuss few basic concepts of correlation and linear regression. Correlation is nothing but a way to determine the relationship between two variables. Let's say we have two variables x and y. So correlation gives you that how these two variables are dependent on each other. Let's say x is a independent variable and y is a dependent variable. So using correlation you can determine that how much y is dependent on x. Correlation is just a way to determine the relationship between two variables. Correlation can be two types, so it can be a positive or negative, or there can be no correlation. For example, if you for every value of x, if a value of x is increasing and y is increasing in a similar way, and you say that there is a positive correlation. So to determine the correlation and the relationship between two variables x and y, you plot a scatter diagram for the variables. Let's say we have a scatter plot. Here we have x, here we have y. So if you see something like this, a scatter plot, it shows that your it's just straight line. So as x is increasing, your y is increasing, so you say that it's a positive correlation. Similarly, if you see something like this, x and you have y and something like this, so here you see that as x is y is continuously decreasing as x is increasing, so it's a negative trend. So you say that there's a negative correlation between the two variables x and y. However, there can be when you say that there is no correlation between these two variables, that time you get a scatter plot something like this. You have y, you have x, it can be something like this. So if you get a diagram like this, you cannot say that what type of correlation it is. What type of correlation it is. For value of x, there can be any value of y. You cannot determine clearly that what, if you have a particular value of x, then what will be the particular value of y. So this is how you determine that what type of correlation, how your two variables are related to each other, how much is the interdependency between the two variables. Correlation is of several types. Basically, to determine, when you say the relationship between the two variables, you measure it in terms of a coefficient of correlation. Coefficient of correlation gives you the degree of a relationship between variable x and y variables. So your correlation coefficient of correlation, it is of several types, just like Pearson's are product-moment of coefficient of correlation. Then you have Spearman rank coefficient of correlation. Then you have a biserial and point biserial. you have chi, sorry, phi. Then there are two more called as coefficient of contingency and tetrachoric coefficient of correlation. But in this session I am just going to use this Pearson's coefficient of correlation. This is what is used in linear regression analysis. Pearson's coefficient correlation. So it's defined by variable R. This its value can range from anything between +1 to -1. Sorry. We say -1 to +1. So if we say that value of R is tending towards +1, we say that X and Y are highly correlated to each other in a positive way. So if we say that R is equal to some 0.9, and we say that it's 90% correlated and it's very much near to +1, so the dependency is very high. Similarly, if we say that R is -0.95, and we say that R is the variables are negatively correlated to each other. However, if we say that R is equal to 0, that means the variables X and Y are not correlated to each other. There is no dependency that exists between X and Y. For any value of X, you can't predict what will be the value of Y. So let's say that we have two variables X and Y. We say X is X, X1, X2, X3 to Xn. Similarly, we say Y1, Y2 to Yn. So if we plot these values on a scatter type on a XY plane, we get a scatter plot for X and Y, and on using that plot we can figure out what type of relationship is there between these two variables. Okay. So now to determine R, what we have to do, we have to calculate XY. So calculate XY, it's nothing but X1, Y1, X2, Y2 to Xn, Yn. Then you take the sum it will be summation xi is equal to 1 to n. This will be equivalent to summation yi I is equal to 1 to n, and it will be summation xi yi I is equal to 1 to n. Okay, so we have these three values. So what we got is summation xi, we got summation yi, and we got summation xi yi. So now how to calculate R? So R is nothing but R is equal to summation xi yi minus summation xi summation yi divided by n upon square root of summation xi square, I is equal to 1 to n, minus summation xi का whole square upon n. Similarly for yi, summation yi का square, I is equal to 1 to n, minus summation yi का whole square divided by n. So xi and yi, summation xi yi, I just define how to calculate it. You have a values xi, you have values yi, multiply each values x1 with y1, x2 with y2 to xn to yn, you get, and take a sum, you get xi yi. Summation xi is nothing but the sum of all the values of x. Summation yi is the sum of values of all y, and n is the number of observations. Number of observations, you can say that the number of readings or number of values of x and y that you have. Okay, for example, if you have 10 values of x, so then your n will be n is equal to 10. The summation xi square, it's nothing but the product of the square of xi. So you have x1 square, x2 square to xn square, and take a summation of it, you get xi square. Similarly for yi square, what you have yi, so square the values y1 square, y2 square to yn square, and take a sum, you get summation yi square. Summation xi ka whole square, it's nothing but the square of the summation xi divided by the number of observations. Similarly for summation yi, and take an individual square root of each of these values. So this gives you the standard deviation. So actually this, if you see that summation xi square minus summation xi ka whole square divided by n gives you the variance of x, and summation yi square minus summation yi ka whole square upon n gives you the variance of y. So if you take a square root of variance, you get a standard deviation. So r, you can say that r is nothing but you calculate something like summation xi yi minus summation xi yi divided by n divided by the standard deviation of x into standard deviation of y. This is how you calculate the coefficient of correlation. This coefficient of correlation is very useful in calculating the regression, in doing the regression analysis. Regression analysis is a way to calculate the value, to predict the value of y if you have some previous data of x and y. So it's particularly useful when you have you need to predict the capacity of any product, whether it can be it can be something like the based on the number of hits or the number of transactions on a database, how will be the response time of the database. If you are if you say tally traffic, so with the increasing number of calls, how your system will behave, what will be the maximum capacity of the system. If you talk of web pages, so the load of a web page, for example, if you are using some www.xyz.com, so if you are opening 10 pages simultaneously, okay, so how the number of hits on a web page, so how will be the response time of a web page, how much load it can handle. So basically the main aim of regression analysis is to predict the value of a dependent variable, provided you have some previous data for dependent variable and in the future what can be the value of a independent variable. So for example, if you have some xi values, some yi values, okay, and using regression analysis you can say yi plus 1 can be with some constant or something like that. What will be the value of yi plus 1 when at x I plus 1? Okay, so this will give you the, using regression analysis you have to figure out the value of an independent variable at some dependent variable with the value of independent variable. Regression analysis is of two types. It can be linear and non-linear. So linear, you generally get a straight line. It can be in positive direction or negative direction, and non-linear you get different curves. It can be a logarithmic curve, it can be sine curve, it can be parabola, hyperbola, or anything. In this session I'm not going to discuss this non-linear regression analysis. Here I'm just going to discuss a linear regression analysis. Linear is again of two types, where you have one independent variable and one dependent variable, and the other is multiple linear regression, where you have one dependent and more greater than one independent variables. In short, I can say this can be something like y is equal to a plus bx equation, a straight line. In a linear regression you will always get in a straight line, and this with multiple independent variables and one dependent variable, your straight line will be something like y is equal to a plus bx1 plus c b1x1 b2x2 so on to plus bn xn. So in this session I am just going to discuss the linear regression analysis with one independent, one dependent variable. I will discuss multiple linear regression in my next session. Basically, they are just two variables. As I just said that linear regression, in this type of linear regression, we have a straight line, something like y is equal to some constant a plus b x. Okay. So now the question is how to determine this constants a and b. So generally what we say is b is given by coefficient of correlation divided by sy minus sx, and a is equal to, when you have b, y minus bx bar. Okay, when we say y bar is summation yi divided by n. When I say x bar is equal to summation xi divided by n, it's nothing but a mean of two variables x and y. Okay, r is nothing but a coefficient of correlation that we have just determined. Okay, now what is Sx and Sy? Sx is a standard deviation of x and Sy is the standard deviation of y. So it will be summation xi square minus summation xi ka whole square divided by n minus 1 under root. It's not actually a standard deviation, it's a standard deviation divided by the degrees of freedom, under root of degrees of freedom. So degrees of freedom, you say that the number of observations minus 1. Similarly, you calculate Sy is equal to summation yi the whole square minus summation yi the whole square divided by n minus 1 square root. Okay. Put these values with b, you get a regression line. So I'll say like this, I'll put all these values in the equation. Y is equal to b is nothing but r under root summation yi square minus summation yi ka whole square divided by n, and this whole thing divided by degree of freedom minus 1, this whole divided by summation xi square minus summation xi whole square divided by n and whole divided by n minus 1 the under root. Okay, and you have x plus you have c. So c is y bar minus this whole thing b x bar. So this b is nothing but this whole value. So again you have to repeat this whole value with this, and you will get you can predict the value of y. This is how you do a linear regression analysis. Multiple linear regression analysis can be done using different tools. Instead of doing mathematically or using formulas, it's good if it's done using some regression tools. One powerful regression tool is Excel. You can have a regression tool there, data analysis tool, and you can do the linear regression analysis for that. So in my next session I'll discuss how to do what is meant by multiple linear regression and how to do that. What are the different terms that we use in multiple linear regression, and how to do it, how to analyze that. Non-linear regression analysis is a little bit tricky because in that you don't know what type of curve it will be. Sometimes in non-linear regression analysis, if you have just two variables, one independent, one dependent variable, then it can be done using Excel again. But if you have more than one independent variables, then Excel will cause a problem. It will not be that easy to do with Excel. You have to use some specific tools other than the Excel to do the linear regression analysis. So that I'll discuss again in my other session. Overall, this is how we do regression analysis and what is meant by correlation and correlation coefficient.